Can you hear me?
पीछे कुछ बोल रहा है, कोई बोल रहा है पीछे. There's some noise in the background. Hello?
Yes, yes.
Yeah, it comes and goes, like not like every
Okay,
time it is
vertical
there.
shift. Consider the graph of three functions shown below. Wait a minute. Okay. Consider the graphs of three functions shown below. Y is equal to x square, y is equal to x square minus 3, and y is equal to x square plus 4. So the main graph, if we're going to the original graph, the main graph original graph is one and the same thing. That is y is equal to x square. This graph y is equal to x square that I'm plotting, pointing with red dot. This is the original graph.
Okay.
Original. And now we need the transformation to the y is equal to x square. We need to plot a new graph, and that graph is y is equal to x square minus 3.
Minus 3, yes.
So we know when we have y is equal to f of x minus 3. And what is f of x here? Function. That is x square minus 3. So when we have to subtract something from the function, it means we are going downwards. We need to move down. So it was x square. So that's what we were learning yesterday.
या फिर कोई बोला पीछे. There's someone talks. Hello?
Yes, yes. Okay.
Yeah.
So we need to move 3 units downward. So it's 1, 2, 3. So this was the original graph. The
Yes.
original graph is at y is equal to x square, but we need to move 3 units downward. So it's 1, 2, 3 from the main vertex. You can see from anywhere, from here, 1, 2, 3. From here, 1, 2, 3.
From
Anywhere
any
of
point,
the graph, you
yes.
can see you are moving 3 units
3
down.
points.
So
Yes.
what we have learned is if we have an original graph y is equal to f of x, we need to, and if we will subtract 3 from this function, it means we are going to move
Go down.
down.
Yes.
Okay, now come to the next graph, and I will use the color brown for this. Y is equal to x square plus 4. So for y is equal to x square plus 4, adding something in the function means move up. So this was the original function. It is 1, 2, 3, 4. So we are moving upward with 4 units. You can check here. 1. This is the original. 1, 2, 3, 4. Moving upward. Okay. 1, 2, 3, 4. Moving upward with 4 units. Are you getting my point?
Yes.
We have an original function. So this is y is equal to f of x plus minus k. In the case of something adding in the function, we need to move upwards. Something subtracting from the function, we need to move downwards.
Yes.
Got it?
Yes.
Okay.
So for this, we will go downwards.
Can I move on?
Yes, I'm getting, hold on, just downwards, and then this one.
At first glance, it may seem that the graphs have different widths. For example, it might look like y is equal to x square plus 4. The uppermost of the 3 parabolas is thinner than the other two parabolas.
Yes, yes.
However, this is not the case. The parabolas are congruent. That is, if we shifted the graph y is equal to x square up 4 units, we should have the exact same graph y is equal to x square plus 4. Similarly, if we shifted y is equal to x square downwards 3 units, we would have the same graph y is equal to x square minus 3. So I have already told you that we are just moving upwards and moving downwards, and all 3 graphs are going to be congruent. Numerically, we can determine that for any value of x, the value of y is equal to x square plus 4 is 4 more than the value of x square. And y is equal to x square minus 3 is 3 less than the y is equal to x square.
Yes, yes.
Understand? Okay. Now we will be discussing each and every point of these graphs. So
Numerical, okay, numerically.
yes, if
ठीक.
we have x is equal to 1, definitely we have the function y is equal to x squared, like value of the y is 5. So x squared plus 4 is 5 plus 4, that would be 9. I don't know why they don't fill it. X squared minus 3. 5 minus 3 is going to be 2. So if it's 0, 0 plus 4 is 4, and 0 minus 3 would be negative 3. 1 plus 4 is 5, and 1 minus 3 would be negative 2. So it's 4, 8, and 1, 25, 29, 22, 100, 104, 97. Okay. So if you understand this, what is happening, if we have an original graph, we need to have x squared plus 4 means we are moving 4 units upwards, or we can add plus 4 in every point and we will get the coordinates, and we can plot these coordinates and we will get the new graph.
Yes,
If
yes.
we have original graph and we subtract 3 from the coordinates, we will get the new coordinates, we will plot these coordinates and we will get the new graph.
Yes.
We can formally express these relationships using the function notation. For any function f of x, the function g of x is equal to f of x plus c has a graph that is the same as f of x, shifted c units vertically. If c is positive, the graph is shifted up, and if c is negative, the same thing that I told you, that if c is something that is numerical value. If it is positive, means shifted up. If c
Up.
is negative, means shifted down.
Down. Yes.
Okay. Okay. Use the graph of y is equal to x square to graph the function y is equal to x square minus 5. So now we have learned how to do so. If we have a function y is equal to x square, we know the graph of the function y is equal to x square, which is this. Okay. And we need to plot another graph y is equal to x square
minus 5, which will do 5 units down.
Shifted down. So it's 1, 0, 1, 2, 3, 4, and 5 over here. From this point, 1, 2, 3, 4, 5 over here. Every point we will move 5 units downward, and we will get a new graph y is equal to x squared minus 5. Okay. This is all about
the vertical shift. Vertical.
We have learned everything about the vertical shifts. Now we will move on about the horizontal shifts. Okay. Consider the function f of x is equal to mod of x and g of x is equal to mod of x minus 3. From the examples of vertical shifts above, you might think that the graph of g of x is the graph of f of x, shifted 3 units to the left. However, this is not the case. The graph of g of x is the graph of f of x, shifted 3 units to the right. That I told you yesterday. For horizontal shifts, it's against intuition.
Yeah, but my question is, how are we going to figure out that this will be a horizontal shift and this will be a vertical shift?
That, speak again.
How can we figure out that
that is what I'm going to tell you. That how we are going to figure out. This is the most important question, and I explained to you yesterday too. That if I have function f of x is equal to x squared, this is the original function. And if I have f of x is equal to x squared plus 2, it is something dealing with vertical shifts.
Okay.
It is either plus or negative, up or down.
Okay.
And if I have f of x is equal to x plus 2 whole square, something added in the x, it is dealing something with the horizontal shifts.
Okay. Yeah, of course.
Okay. So if we have something added to the complete function, it means it is vertical shifts. And
vertical,
if in the particularly x value, it means it is dealing with the horizontal shifts. From the examples of vertical shifts above, you might think that the graph of g of x, okay, what is it telling? That if it is f of x, and if we have x plus 3, it means we need to move up. Similarly, if we have f of x, this is f of x, originally it is f of x is equal to x. If it is x plus 3 means move up. So if it is x plus 3, the intuition says to move right, but you need to move left. And if it f of x is equal to x minus 3, the intuition says to move left, but you need to move right. In the horizontal case, it's opposite. We have to go
let me write it down. Let me know.
Okay.
Yeah.
Now we have x, and g of x is the absolute value of x minus 3. So if we have 0 and absolute value of x minus 3, we need to calculate all of them. Okay, 0 minus 3, which will be equal to absolute value of negative 3, which is equal to positive 3. For 1, 1 minus 3, which is equal to absolute value of negative 2, which is equal to positive 2. 2 minus 3 minus 1, absolute value. Do you know this mod function makes every negative value positive?
Yes, yes, I know this. Yes.
Yes, so I'm working on it, okay? So it will
Okay.
make 1. I have 4 minus 3, which will answer 1. 5 minus 3, which will answer 2. And 6 minus 3, which will answer 3. So using x values, we get the value of g of x mod x minus 3. Now we will see how to plot it. Okay. This is the original function f of x is equal to mod of x. And this is the function mod of x minus 3 shifted towards right. So what we have learned is, in the horizontal case, negative means right.
Yes. Like it looks like it will go on the left side, but it's against the intuition, so it will go on the right side.
So it's 0, 1, 2, 3, moving right. Okay, if this is the point, 1, 2, 3, moving right. If this is the point, 1, 2, 3. So everywhere from the graph, if this is the point, 1, 2, 3, moving right. Okay.
Okay.
Also, you can make another coordinate and you can follow the points of the coordinate to draw
Hold
new
on, hold
graph
on.
as like this
Okay.
in the table. But if you
Okay,
don't
okay.
want to make another coordinate, you
Oh,
can
can you move it again up, because I need to figure.
like
Oh, where it is. Yes. Just for my reference.
on the diagram. Okay.
Yes, yes. Hold on. I'm gonna write it down here. Oh. Okay. Blue will be. Okay. Ow. Okay, this is original. F of x equals to mod x, and this is g of mod x minus 3. Okay, done.
Okay. So if we have f of x minus a means horizontal shift
Yes.
towards
Right side.
the right side. Very good. And f of x plus a means horizontal shift.
It will be towards the left side. It looks like it will go on the right, but it will not. It will not horizontal.
So I think today you are getting my point. Yesterday you weren't able to understand anything.
Yeah, towards left.
Okay. Note that in the case of the horizontal shift, the
x
constant
plus
is the part of the input of the function. For example, y is equal to x plus 7 whole square represents a horizontal shift of the original function y is equal to x square. So if we have a function y is equal to x plus 7 whole square. So whatever the constant is part of the transformation. It means if we will remove the constant, we will get y is equal to x square, which was the original function.
Hold on. X again going to.
So what is happening? You are always given an original function and you are asked that the transformation is x minus 7 whole square. But what happens? If it is opposite, if you are given a transformated function and asked what was the original function, so remove the constant and the part left after the constant is the original function. Okay? Getting it? Similarly, in the y for the vertical case, if it's y is equal to x square plus 7, and someone asks you to find the original function, remove the constant, and y is equal to x square would be the original function.
Okay.
Okay, now what is the relationship between f of x is equal to x square, g of x is equal to x minus 2 whole square minus 6. So very, very important and very easy. In some, adding or subtracting constant within the domain of the function, it creates a vertical or horizontal shifts in the graph. Inside the parenthesis, we should be horizontal. So x minus 2, what shift?
Horizontal. It will be it was a negative. Yeah, it will be the horizontal shift towards right.
Towards right. Towards right. By 2 units.
2 units, yes.
And negative 6 means
up and
Down. Negative means down. Vertically,
This will be vertical shift, no?
yes, vertical towards down by
Yes.
6 units.
Yes.
Getting it?
Yes, yes.
Stretching and compressing graphs. Okay. If you multiply a function by a coefficient, the graph of the function will be either stretched or compressed. Consider the graph of 3 parabolas below. The original one is y is equal to x square. This graph. This red one. This is the original.
Yes.
If we multiply 10 with this graph, we will get this graph. This one, green one. And if we divide it by 5, we will get this graph. So what we can observe it, if we will multiply a graph with a number, a whole number, it is going to be compressed. And if we are dividing with a whole number, it is going to be stretched.
Okay.
Understand?
Yes. Compressing and stretching.
The widest parabola is the function y is equal to 1 by 5x squared. This is the widest one, the last one. The middle parabola is the function y is equal to x squared. The thinnest parabola is the function y is equal to 10x squared. From these graphs, we can see multiplying by different coefficients has different effects on the graph. The graph of y is equal to 10x squared represents a vertical stretch. Every function or value of y is equal to 10x squared is 10 times the equivalent to the y is equal to x squared. For example, y is equal to x squared contains a 0.24, while 10x squared contains a 0.240. The coefficient 1 by 5 has an opposite effect. This is vertical compression. So, main thing to learn over here is, when we are going to multiply with a whole number, it is going to be vertical stretch. And when we are going to divide it, it would be a vertical coefficient, opposite effect, compression. Understand? If it is said that y is equal to x square, change to y is equal to 5x square means it has a vertical stretch by 5 units. But if it is 1 by 5x square, then what is the compression of 5 units? Compression means to expand, stretch means to become thinner. Okay? We can formalize vertical stretching and compressing as follows. A function g of x is equal to c f of x represents a vertical stretch if c is greater than 1. And a function h of x, c f of x represents a vertical compression if c is between 0 and 1. This is what I have done in the last table. The table that I formed yesterday, I do mention that there are 2 points. I do mention c is greater than 0 and less than 1. Will represents vertical compression, and if it is c greater than 1, it will represent vertical stretch. Remember in the table?
Yes.
Don't remember?
No, it's obviously I don't remember everything, but the table is here in front of me, so I can see.
Okay, so you can see there. Can you see that I mentioned c between 0 and 1 and c between greater than 1?
Yes.
Okay. Note that the graph y is equal to 1 by 5 x square is wider than other 2 parabolas, while 1 by 5 has the effect of compressing the graph y is equal to x square vertically. We can also describe the graph as having a horizontal stretch. Formally, we characterize the transformation as horizontal stretch or compression if the function of the form g x is equal to fc of x. That is, instead of multiplying the function by a coefficient, the variable x is multiplied by c. We analyze the quadratic equation. We can see why vertical compression looks like horizontal stretch. Okay. Consider, for example, the function y is equal to 3x squared, 3x whole square. We have multiplied x by 3. This should affect the graph horizontally. However, if we simplify the equation y is equal to 9x squared, Therefore, the graph of the parabola will be taller, thinner than y is equal to x square. So y is equal to 9x square. If it is 9, like y is equal to x square has the graph this. And y is equal to 9x square will be have taller and thinner graph. This will be 9x square and this will be x square.
Okay.
Multiplying with the number makes the graph taller and thinner. Now, next example, 1 by 2x square. If we simplify the equation, 1 by 4x square, multiplying by number x between 0 and 1, horizontally stretch the graph. So 1 by 4x square will be like this.
Expand.
I think you are getting my point.
Yes.
A function g of x represents a vertical stretch of f of x. If g of x is equal to c, f of x and c is greater than 1. A function g of x represents a vertical stretch whenever c is greater than 1. Represent vertical compression between c is 0 and 1. Horizontal compression c is greater than 1 and horizontal stretch between c is 0 and 1. Just take a minute and look these 4 points.
So g of x is the vertical. Okay. Okay. Yes. Yeah.
Done?
Yes.
Okay, now I just need 1 minute to, I'm going to share screen again.
Okay.
Wait a minute. I was thinking, can you see the screen?
Yes.
Because we are just studying and it was not making you understand better. So come up
Yes.
with these questions. Consider the function y is equal to f of x graphed below. Reflect f of x over the x-axis.
Okay. What is the equation for this new graph?
Do you know how the reflection occurs? No, you don't.
No, I
X
don't.
values will remain same.
Okay.
X coordinate remains same. You can write it because I will erase it.
Yes, I'm writing it. I'm writing it function.
Okay. Y coordinates turn opposite.
Y is equals to fx. Reflect x over x axis.
Let's see this graph. This is
Okay.
1, 2, 2 from the horizontal and 1.
Erika, the y coordinate turns opposite, x coordinate remains same. Reflect matlab.
Okay.
Reflect.
I'm just going to write the coordinates here, and this is important to understand. This is 1, this is 2, 1, 3, 4, -1, -2, -3, -4. Similarly, it's going to be 1, 2, 3, 4, -1, -2, -3, -4. So this point is 2 from the x-axis, 3 from the y-axis. This point is x from the 1 from the x-axis, 0 from the y-axis. This you can speak.
Huh? 1, 2, 3. Oh, this is
Point
4.
is
This is sorry, which one?
this point.
This one is 4 and -1. I mean,
Wrong.
-1 and 4. -1 and
Minus
4.
one. This
Yes.
point
This point is -3 and 4.
and this point.
This point is -5 and -4.
Okay, here I'm going to write the x and y coordinates.
Hmm.
Okay, starting from the first point, it was 2 and 3. Then it was 1 and 0. Then -1 and 4. Are you understanding what I'm doing?
Yeah. I'm actually writing it down also. That is why I'm not talking, because then
Okay. Now this is what I have done about the original graph, but I need to reflect it over x-axis. So when we will reflect it over x-axis, we need to make the x-axis same. 2, 1, -1, -3, -5. X coordinates will remain same and y will go to the opposite. -3, 0, -4, -4, +4. This is the new coordinate for the reflection of the f of x.
Okay, new
Can
coordinate
I
for
move
reflection.
on?
No, please hold on. It was x5 will be 2, -3, 1, 0, -1, -4, -3, -4, and -5 and 4. So reflection will be just opposite sign of it.
Yes. Opposite sides of only y coordinates.
Opposite sign. Okay.
Okay.
New coordinate.
Let's plot. 2 from the x-axis, -3 from the y-axis. 1
Oh,
and
we're running out of time, just letting you know.
-1 and -4. -3 and -4. -5 and +4. 1, 2, 3. Can you see the red dots?
Yes, I can. Ah, okay, now I get it.
Reflection over
Okay.
x-axis.
This is actually reflection of it. Okay. Okay. Hence the word reflection. Okay.
Now you can actually understand the meaning of the word reflect.
Yes, now I can actually. Okay.
Coming to part B, I'm going to erase everything, right?
Yeah, do it. I've done already.
Now you're going to help me out.
Okay.
Yes, coordinates.
So this is your 1, 2. So this is minus 2 and 1, 2, 3. 2 and 3. And this is 1 and this is 1 and 0. And this is which one? -1 and 4. And this one is -3 and 4. And the last one is -5 and -4. So it was x and y will be.
But the question is changed. Can you read the question?
Now, yeah, it's on y axis. So that is x will remain same and y will change.
Yes. No.
Okay. Huh? 2 and 3. 2
What
and
did we do in
1.
the last question?
So we on over x.
Just check your register. What have we done in the last question?
So it has the reflection over x-axis. So in
No,
x-axis.
where it is asking x-axis. Okay, in the last question. Okay. Hello.
Yes.
In the last question, it was asking x-axis, but here it is asking y-axis.
So that is what I'm saying. I'm saying the y will remain same and x will change.
Yes, yes. Now you are right.
No, this is what I said the first time also.
Okay, I'm sorry.
I was like, what did I do wrong? Okay.
Okay, -2.
-3 and -5,
Minus,
and this
minus
one is
2 and plus 3.
3, 0, 4, and 4, and
-1 and 0. 1 and 4.
so now the new ones will be this one, x and y, x and
3
y
and
will
4.
be -2, -1, 1, and
5 and -1.
3 and 5. And this will be 3 and 0 and 4 and 4 and 4 and कुछ छूटा है बीच में.
See how beautifully we have reflected over the y-axis.
Yeah.
This is the y.
So this is not that difficult. This is actually easy. You
Yes.
just have to be sure what we're doing. Yes. Yeah. Now, एक second, hold on. Let me draw this. This one, and the next one will be like this. Okay, done.
Remaining meeting time.
Sorry, I'm done.
Okay. This is f of x. And the purple graph is f of x plus 4.
Where?
So
The purple?
this is the original graph f of x. The purple graph is f of x plus 4, which is a new graph. So how we have formed the purple graph?
I cannot see the purple one. It's just like the same page is coming.
This is the purple one. Okay, I'm marking it with the green.
Is it the purple? It's a black.
Okay, whatever color it is, instead of black.
Yeah. Okay then. I thought you went on the next page and then you're telling me another one, and the
Okay.
page is still coming.
Okay,
Yeah, fine.
how did we get this graph?
Okay.
Can you describe in words it? What did we do?
The reflection, we found the reflection, the new coordinates for x-axis. I mean for y-axis.
How?
So if the reflection is over the y-axis, so we actually marked all the points. We got the coordinates first of
shift
x and y,
4
and then we
units upward. When I say you to describe in words, it means we have shifted our graph 4 units upward. Is it correct?
No, we have moved towards the right side.
Right side? Where are we going towards right side? Check. I'm
Which
using
one?
red color. This is the red point.
The B one, right? The B one, f of x, the same one you are using, right?
We're doing a part.
Part A, but you are showing part B to me here.
No, I'm working on part A.
No, the page here is part B. Wait, I'll send you the picture. Hold on.
Okay, can't you see part A?
No,
Oh
here.
my
This is
God.
that is what I'm saying. See, this is what it's showing to me. This
Okay,
one.
wait. What is happening? Now can you see part A?
Nope. Still not. Still the same one. I sent you the picture.
What's happening? I hope you can see it now.
Nope.
No?
Nothing. No.
We need to reshare the screen.
Yeah, you know what? Maybe the time is also going. Maybe you have to
Okay.
send me link again. Yeah.
Okay.
Let's end it and you can come again.
Okay. I will
Okay.
leave the meeting and send you again. Okay.
Okay.